You're listening to the Decarbonisation Dialogue, a podcast from Salix.
Welcome to Delivering on Climate Change, our collective challenge. Welcome to the Decarbonisation Dialogue. I am Hannah Walker, and I believe that the best way to communicate a message is by being passionate about what you are talking about. Through that passion, I believe you take people with you and create action using your influence to make change and make a difference. Today, our task is to get all of us to net zero. My guest today is Professor Helen Findlay, who's going to talk to us about all things ocean and climate. Professor Helen Findlay joined the Plymouth Marine Laboratory in 2006 to do her PhD on ocean acidification and climate change impact on marine populations. Helen is interested in understanding the effects of climate change and ocean acidification on marine ecosystems and the application of this knowledge to maintain a healthy and sustainable ocean. She uses a combination of experimental, observational and modelling tools to investigate the impacts of climate change and ocean acidification on marine organisms and ecosystem functioning, with a particular focus on the Arctic. She is a member of the Executive Council for the Globe and Ocean Acidification Observing Network and lead coordinator for the Northeast Atlantic Ocean Acidification Regional Hub, which aims to establish accurate global monitoring of acidification, share knowledge and build capacity to underpin solutions. Helen also contributes to raising public awareness of ocean health and to training the next generation of scientists through school and educational programs and focusing always on solutions. That's quite a lot, Helen.
That is a bit of a mouthful, yeah. Well done for getting all that.
Now, I'm not a scientist. I'm certainly not a climate scientist. I'm not a biologist, but there's quite a bit there in terms of ocean acidification that I really do want to explore further in this podcast today. But first, tell us a little bit about your career. What led you to study the ocean and inspired you about marine science?
It's always a tricky one when people ask you that, but I think it came down to two things for me. I wanted to be a marine biologist since I was about the age of 11, and that was primarily, I think, because we spent a lot of time by the sea and we went sailing a lot and did a lot of things by the sea as a family. And so I was kind of just became obsessed with it a little bit, and at the age of sort of 10, 11, got birthday presents of whale and dolphin kind of conservation society magazines and things like that. And then my mum also did an Open University science degree over 7 years when we were kids growing up. And I can remember being maybe 8 or 9 and her talking about photosynthesis and measuring the distance to the moon using a broomstick out of my brother's window, things like that. And so I think it was that combination of science that she brought and kind of the marine experience that led me down this path.
That's your mother. That's absolutely fantastic that she was studying. And I'm not sure, were you interested at the time, or was that kind of learning just going in through osmosis, like as kids do? Perhaps you might be interested in something else, but she's obviously setting a benchmark there, isn't she, and setting a tone for your future.
Yeah, she did. And I think it was a bit of both. I suspect now having my own kids at a similar age to what I would have been, I can appreciate how much they probably don't pay too much attention, but actually they kind of do absorb a lot, don't they, at that age? So yeah, I think even if I didn't particularly think about it as something that as a kind of a career per se, just even remember walking to school and the leaves were changing colour and she would be explaining why that would be, and that was because she was doing that degree. So it's just this general interest in nature and science, I think.
That's amazing. That's a lovely story, and obviously your love of the ocean and just spending so much time at the sea and sailing and understanding how that is very much part of your life, and obviously is a huge part of your life today. So we're talking and looking at massive challenges as we face climate change. Can you tell us what's happening to our oceans? Because you've studied and study ocean acidification, which is something about carbon dioxide levels rising and the pH volume of the water decreasing. As I say, I'm not a scientist. I can't pretend to know anything about this, but can you explain what this is and what's it got to do with climate change?
Sure. So I'll give it a go and you can tell me if you understand it at the end. So most people familiar with climate change as we're adding greenhouse gases into the atmosphere, and that's causing warming in the atmosphere. It's also causing huge amounts of warming in the ocean. So the oceans do us a huge amount of favors. They take up 90% of the heat from the atmosphere. So they are warming incredibly rapidly, but because they're so large, they can do that. They have that great expanse. But they also take up carbon dioxide for us. So they're taking up about 25%, a quarter of all the carbon dioxide emissions that we're adding to the atmosphere every year, and that's going into the oceans. And so that's actually a really good thing, because without the oceans taking up that carbon dioxide, that would be staying in the atmosphere, and the atmosphere would be getting even warmer. But actually, as a cost to that, we have this problem of ocean acidification. So what's happening is that when carbon dioxide goes into the water, it dissolves and it reacts with water to form a weak acid called carbonic acid. In the sea, hopefully everyone recognises the sea is salty, and it's salty because it's got these different ions in it. And some of those are things called carbonate and bicarbonate ions. And those come from weathering of rocks. So if people are familiar around the UK, for example, we have a lot of limestone and chalk cliffs. And those chalk cliffs are made of calcium carbonate minerals. And so over really long geological timescales, those minerals get washed back into the sea. And that's kind of one of the things that gives the sea these ions. But they're really also important for carbon dioxide. So when it becomes this carbonic acid in seawater, so it's reacted with the water, it's become carbonic acid, and it can actually change into these carbonate and bicarbonate minerals as well. So it kind of transitions between those three. And over really long geological timescales, if you add CO2, it's balanced out by this weathering effect. So we don't get any change in acidity over those long timescales. But what we're doing is adding so much carbon dioxide so quickly, and it's the speed that we're adding that carbon dioxide. Those long-term geological weathering processes aren't able to keep pace. And so that acid is actually just staying as acid in the oceans, and that's what's making the oceans become more acidic through time.
That is very clear. The oceans are doing their good job, and they're doing the right job over centuries and centuries by absorbing that carbon dioxide. But what you're saying is it's going too fast now. It just can't keep up. So the acid levels, the acidification is rising. Tell us a little bit about the work taking place at the Plymouth, because I want to know all about the Arctic and your work in the Arctic and the polar regions. That's fascinating. But what work is actually taking place at the Plymouth Marine Laboratory? And how do you measure this? How do you measure the pH? How do you measure that acidification?
So we do a number of different things at PML. As you said in my introduction, I use modelling, observations and experiments. So we do all of that, and it's not just me. There's a whole of PML. We have 180 people here working in these different various aspects of it. So for example, we have the modelling group who are looking at creating computational models that actually can look at what the ocean is doing and how it's changed in the past and predict how it's going to change in the future. So they're a really useful group of people that are able to look into the future and see how it's going to look in the next 50 to 100 years or so, or even longer. Then we have the kind of observational side of work that we do here. And we have what we call long-term time series stations. So just off of Plymouth, which is where we're based, about 7 kilometres offshore, we have what we call the Western Channel Observatory. And that's a series of buoys and measurements that we take over long periods of time. So the Western Channel Observatory has been going, it's one of the longest time series stations in the world now. We've been measuring temperature and salinity here since 1903, so over 100 years worth of data in terms of temperature, and that allows us to see these long-term climate change trends of, for example, warming in the ocean. And since about the early 2000s, since I did my PhD, we added carbonate chemistry measurements to that. So that includes being able to monitor for ocean acidification. So we can directly measure pH, and we do that using sensors that are able to detect the change in those ions, those hydrogen ions. But actually, more routinely, what we do is take samples every week at that station for dissolved inorganic carbon, which is the total amount of carbon that the ocean has, and the total alkalinity, and that's kind of the buffering capacity, if you like, those with minerals that come in and buffer that change in acidity. And through measuring all of those parameters together, we can then see how ocean acidification is manifesting in the area. And we've been measuring, like I said, for about 15 years now for ocean acidification parameters, and we do see a clear trend of the acidity increasing in this region. And that's the sort of observations that we have around many places around the world. So there's stations like that, so observation time series at numerous places around the world that are all showing the same thing. And then the final thing that we look at here, and that I've been involved with a lot through my time here, is experiments and sort of looking at what that means for the biology. And so what we try and do initially, very early on, when ocean acidification kind of became this thing that we suddenly were aware of and we didn't know much about, we started doing quite simple experiments of sort of taking an organism in today's conditions and putting them into sort of future conditions, and what will happen to that organism. Can they survive? What changes in their physiology? And so we've done that here around the UK, but we've also done it elsewhere. I've done it up in the Arctic. And so we're interested in combining that experimental knowledge, what can we work out and what can we learn from lab experiments about changing biology, to matching that with what we see in the real environment in terms of the observations both here and elsewhere around the world.
What's it like working in the Arctic in those kind of conditions?
Yeah, cold. I'm kind of obsessed with the Arctic. I think once you go and experience that sort of remote location in the way that we get to experience it as very privileged scientists that get to go and experience that remoteness, you kind of just fall in love with this environment. But it's incredibly difficult. It's very cold, stating the obvious, but that makes things really difficult to work. So electronics don't work quite so well, especially below about -25. So it depends when you go. Obviously, if you go in the summer, it's much warmer and much easier. And if you go on a nice ship, then generally you kind of have the same facilities available that we have in the lab. And we also we have the UK Arctic Research Station up in Svalbard, and that's a nice facility that's run through the Norwegian government. But the UK has a station there, and we've got good lab facilities and eating and bedroom facilities. But then we also do remote field work, and one of my two favorite trips have been where we've been camping on sea ice up in the Canadian Arctic for 2 months at a time, just living in tents like we would do here. That's incredibly challenging, but incredibly rewarding, because you know that very few other people have gathered the data that you're able to get in that situation. So yeah, very privileged to have done it, but it's not for everyone.
Yeah. But that love obviously inspires your work, but through that work you're also seeing a picture that doesn't look so positive for our planet.
Yeah, it's a difficult one, isn't it? Because as a scientist, I spent the first probably 10 years of my career watching this unfold, and we're still watching it unfold. And then you get to the point where it's like, well, we're not really doing enough about it. And do we really just want to watch it happen, or do we want to start to sort of put solutions in place to try and make things better and stop this from unfolding? And particularly the Arctic, when you go and experience that environment and that wilderness and the organisms that live there, the creatures and people that live there, and they live in such a sustainable way, but they're being influenced by everything that's outside of their control, really. And it's quite hard to kind of, I don't know, deal with, get your head around a little bit. But the Arctic is changing so rapidly. It's warming. It's got this acidification issue. As you mentioned, you've got all the ice melting, the Greenland ice, permafrost ice. So everything's going on.
Yes.
In the Arctic.
Now you've talked about the ions, the bicarbonate, and you've explained that very well. The carbonic acid. But you've also done some research, or you understand oysters, because I want to talk about oysters for a moment. I'm lucky enough because I spent a lot of my time in Maine in the United States on the coast, on a very remote part of the coast. And as I say, I'm not a scientist, but over the many, many decades I've been going there, I've seen a change. What's happening to that on the because I know that there's a change, because the people who are fishing, the local people are noticing a change in what's happening to the oysters, and why does that matter?
It comes down to how acidification can impact organisms. So it's kind of, because it's a chemical change, it's very difficult to sort of see impact happen, which is one of the problems with us not responding to, I think. But there are creatures that are more sensitive than others, and oysters are one of those that we have found actually being impacted today in today's world, if not for the last 15 or so years. The reason for that is twofold. So just like you and I have to regulate our internal pH, we do that because we need to build enzymes, we need our brains to function properly, and that all depends on our internal physiology. But we're doing that in the atmosphere, and we've not got all these ions we need to balance that out with. Marine creatures have to do exactly the same thing, and some are much better at it than others, but they're doing it in this soup of ions, which they have to exchange across their membranes and their gills and whatever else. And so it makes it more energetically expensive for them to do that as we change that ionic soup, if you like. So as we acidify the ocean, we're changing that composition, and it makes it more energetically expensive. And oyster larvae in particular, and early life stages of many organisms, are particularly vulnerable because they're so early in their development. They haven't got those physiological processes in place yet that are able to balance out their ions. So oyster larvae, we know, are really susceptible. The other thing that they're doing is they're calcifying. So as they develop from these larvae into the oysters that we know, they're producing these calcified shells. In more acidic conditions, it's much harder to do that because the shell essentially wants to give up its calcium carbonate to balance out that acidity. And so it's another energetic cost for any calcifying organism. So oysters are sort of doubly impacted by that. And now on the west coast of the US in particular, what we have is a situation where you've got acidification happening globally, but actually the oceans have the way that they circulate means that the deep oceans actually hold a lot of the carbon dioxide. And if you get that carbon dioxide upwelling onto to the surface, which happens in certain places around the world, and one of those is the west coast of the US, then you get that deep water, low pH, high CO2 water coming up to the surface. And so that's been happening for hundreds of years, but it's not had the same level of acidity that we now are seeing. And so over the last 15 years or so, actually that's become worse and worse, and it's been impacted because of acidification. And so oyster hatcheries around the US have had to really start monitoring the water they intake. They've seen whole populations die out because of acidification. They've had to move locations of some of their hatcheries, for instance. And so they've really had to put in place over the last 5 or 10 years these big adaptation plans where they're really looking at focusing on how they can make, even to the point where they're kind of trying to breed more resilient oyster species, things like that, to actually be able to continue to keep growing oysters.
Thank you.
And so they're kind of a sentinel species, if you like, for acidification.
Super. And I say thank you for explaining that, because it means that when I'm there later in a couple of months' time, I can say, look, listen to this podcast, because I might not be able to explain it to my family and friends, but Helen can certainly explain it. So thank you very much for that. Now, moving on, the scientists are doing a huge amount of work, but what about governments? Do you think governments are doing enough? Because there are obligations for countries to tackle this acidification, and that's enshrined in international agreements, etc., including the Global Biodiversity Framework. Is this work going fast enough, and are there alternatives? I think I was looking at geoengineering and finding ways to remove carbon from the seas. And what's your view of this?
So the short answer is no, we're not moving fast enough. And that's really the government incentive. So I haven't moved enough and the lights have gone off. The government incentive to kind of implement change is so at the whim of politics, really, that it slows down the ability of us to put in place things that allow change to happen rapidly. And we know we can change rapidly. I mean, look what happened in COVID. We did what we were supposed to do, and we shut down things, and things changed. And I think we know we can make change happen when we need to. And things are changing. And I think there's some positive stories that we don't necessarily hear about, which maybe we should hear more about. For example, the UK carbon dioxide emissions are now at their lowest level since the 1970s, I think it is, something like that, which is a really great step. But it's not fast enough on the global scale. And so things like the IPCC, or the International Panel on Climate Change, and the United Nations Framework on Climate Change, Convention of Climate Change, those are trying to get 200 countries to agree on something. We all know geopolitics right now is a very difficult beast. While we do try and take our science to those sort of forum and get involved in that and make sure that the science is clear, I think what needs to be done is much more at a national level, and getting national governments to commit, like the UK has enshrined in law, their commitment to climate change. And then it needs to almost be above politics, and that's the way to do that, is to enshrine it in law, so that it makes it much more difficult for someone new coming in to change that system. Yeah, we could do with moving faster. I mean, this is an issue that we've been talking about now since the 80s.
Yes, it's not new.
It's not a new issue. And all we're finding out, I think, as we watch it go forward, is that with more certainty of things that are happening, and we see it more and more each day in the news of the impacts of that. And 10 years ago, we were saying, by mid-20s, we're going to be seeing this happen, and now we're seeing it happen.
You're right. We are seeing it every day, and ocean acidification is a huge issue, as just speaking to you. But we don't talk about that, I don't think. The general public don't talk about that, because when we're trying to change our behavior, we talk about plastic. We've all seen pictures of the sea life impacted by the plastic wrapped around sea creatures' necks, or rock washing up on our shores. Do you think we're not communicating this very well?
It's a really difficult thing to communicate, I think. I think people are scared off a little bit by the chemistry. It's also, so when we try and communicate it, I hope that we try and do it quite well. But it's an unseen problem. Unlike the plastics, you do have these images that you can refer to, whereas we've had journalists come to us and say, well, show us a dissolving shell or something that I can visually give to someone. It's like, well, it's not actually going to look like that. But there are ways that we've had success, I think, and maybe we need to get better at doing that. For example, we have colleagues in Sweden and Chile who have been working on the taste of shellfish and how the taste of shellfish changes when you eat it. So although they visually might not look different, but acidified shellfish, if you like, versus something that's been in past water, like present day water, actually tastes different, and people can experience that themselves. So there's ways that we need to get better at it. But I think the oceans generally suffer from the fact that we all live on the land, and unless you're very much involved in the oceans day to day, it's a very difficult thing to kind of keep in your headspace when you've got to think about where you're living or your food or all these other problems that people experience day to day. So it is difficult. But I think coming back to your previous question about solutions, I think there's lots of things that we can do, and it's all about our sphere of influence. And you said that kind of in the introduction, using your sphere of influence. And it might be that you just have a conversation with someone, and that is your sphere of influence. Or it might be that you invest your money slightly differently, knowing these things. And I think money is such an important thing in today's society, unfortunately. I think that where you buy your clothes, or where you spend your money, or where you invest it in your pension, all of these things, we have sustainable pension trusts, for example, that we can use. They can all help, and they are all things that like I can do as an individual. In addition to the things that we hear about, like getting solar panels or electric vehicles or turning the lights on and off, things like that. So there's kind of other things I think we can do that are maybe not spoken about as much. So I think really thinking about where your money is going is hugely beneficial.
Taking a bit more thought about the decisions that we take. So turning the conversation back to you, what next for you in your career? Are you going to be spending more time in the Arctic, less time, and tell me a little bit about the lifestyle that you lead. Do you still live near the sea? Are you spending a lot of time in the water on our coast? And your career going forward?
Career-wise, I would love to get back to the Arctic. We're in a kind of proposal writing phase, if you like, at the moment. So we're always looking for new funding for projects and ideas. We've got the International Polar Year coming up in 2033. So that's there's lots of planning for that happening at the moment, which is quite exciting. Hopefully that will feature in my future in the next 5 to 10 years. Definitely some more polar stuff. We are moving a little bit into the marine carbon dioxide removal space. So we haven't talked too much about that, but that's where we're looking at solutions that the ocean potentially could take up additional carbon dioxide. We're here at PML, we're very much independently assessing those as to whether they're feasible. We don't think we should go and rush into any of these things. We need to make sure that they are effective, they actually do their job, and they are safe, and they don't have any unintended consequences. And so we've been kind of making use of our knowledge in the ocean acidification world and climate change world to sort of look at those situations and moving a bit more in that direction. So we have projects involved in that sort of thing. So I think that will be going on for the next 5 or 10 years or so, as we kind of filter out the ones that are pie in the sky and will never work, and the ones that have more legs in them, I suppose. Day to day, I moved out of Plymouth just to the countryside, so I'm up a bit more in farming territory at the moment, but we're still only half an hour or so from the sea. I have 2 young kids, and we love to go to the beach. My parents still sail, so hopefully we'll get out on the boat a little bit with them over the summer holidays. Very much still involved in the sea, and love snorkeling, and my oldest was watching a shark documentary, telling me how much he wants to get into scuba diving. So maybe that will be on the cards again. I haven't done it since I had kids, so it's quite nice to.
And that they are the future, aren't they? And I know that, we're running out of time on this podcast, but I'd love to know more about that research you were just speaking about, but also another time to hear about your work educating the generations to come, because just as your mother inspired you, you're obviously inspiring your own children, but obviously it goes further than that with all of the work and the outreach work that you're doing. So thank you very much to Helen for joining me today and providing such incredible insight. There can be no doubt that climate change is the biggest challenge of our time. Today, we must reduce greenhouse gas emissions to slow global warming. Today, we must act for tomorrow, adjusting our lifestyles to current and future impacts of climate change. Today, we must use our collective wisdom to deliver on our climate commitments. Today, we work for tomorrow's world. Don't forget to subscribe to our podcast channels. We'd love to hear your ideas. Please do email us at podcast@salixfinance.co.uk. Once again, thank you very much to Helen for joining me today. Thank you.
Thank you for having me. It's been great.
You've been listening to the Decarbonisation Dialogue, a podcast from Salix. For more information about our work and to find more content, please visit salixfinance.co.uk/podcasts.